Welcome back to Let's Make a Game, a channel about making computer role-playing games using the free program Twine and the Sugarcube format for Twine. A few days ago, I demonstrated a system for choosing members of a party from a set of different character types. And in this video, I would like to demonstrate a new version of that system with some more advanced options. And the specific advanced options are different character costs, having limits of the number of particular classes that can be in a party, and having incompatible classes. So in a tabletop game, you generally want to make the different classes, if you have different classes, you want to make them roughly as good as each other, generally speaking. And the reason for that is that usually each player, you'll have multiple players, and each player will be playing a single character, and you don't want one player's character to be way better and to sort of overshadow the other players. You want everyone to be able to sort of contribute to the game, take part in the game. But if we're making a computer game, which is going to be played by a single player controlling the whole party, even if we're basing it on tabletop games, either the sort of general tropes of role-playing or a specific game even, we don't have to have the classes be of equal value. And in some settings, it might make more sense to not have them of equal value. If you had a setting that was similar to that of Lord of the Rings, it wouldn't fit that setting very well to have an ordinary hobbit cost the same as a wizard. If you were making a setting that was similar to Game of Thrones, you probably wouldn't make a knight cost the same as a commoner. The commoner might be able to do things that the knight can't, but still you would probably find that the knight was more useful for surviving in that setting, and you'd probably just straight up make the knight cost more. And similarly, a hobbit might be able to do things that a wizard can't, but still you'd probably find that a wizard was more valuable than a hobbit to winning the game. So you might want to have a point system where you have a certain amount of points, but different character types cost a different amount of points. Limits on numbers in a party might be due to rarity. You might say that wizards are very rare in this setting. It's not like every village has a sort of village wizard. They're quite sort of remarkable and unusual, and so you can have one in your party, but you can't have more than one. And in fact, that's what I've done in this demonstration. And incompatible classes, that might be for mechanical reasons. It might be that there's two classes who have abilities that are fairly balanced by themselves, but when you combine them, there's some sort of combo that they can do that's a bit too good, and so therefore you say that they can't adventure together. That's a bit of a it's not an ideal solution, because it does raise the question of why in the game, why aren't these adventurers, why are these types, why weren't they associated with each other? Because the people in the fiction of the world don't know about game balance, right? But that can be a fix. It might be better to just to adjust their abilities, but that can be a fix. But a better reason for incompatibility is world building. So if in your setting, ordinary people fear and hate wizards, well, you might want to put limits on who will adventure with a wizard. You might want to say that a peasant character can't be in the same party as a wizard. You might have rival, excuse me, you might have rival organisations. So this particular type of wizard won't adventure with this particular type of wizard. This type of knight won't adventure with this type of knight. This species won't adventure with this species because they're at war. So they can be that can be a sort of good way to give information out about what your world is like that isn't just a wall of text, right? It's a way of demonstrating how the world, how you think of this world. In this particular demonstration, I've said that knights won't adventure with thieves, perhaps because knights are chivalrous and upright, and so they won't, adventure with lawbreakers, or perhaps it's a class thing. Perhaps knights think of themselves as, born a cut above, and adventuring with low rogues is sort of is beneath them. So let's have a look at what this looks like. This looks the same as the one that I demonstrated a few days ago. You'll only notice a difference once you click on a picture and get the hover text. So now, well, actually, no, that's not true, because it does say you have 25 points to spend, which wasn't there before. So we can see that a knight costs 10. There's a maximum of 2 per party. Perhaps they're, fairly rare, and they're incompatible with thief. Barbarian costs 5. There's no limit to how many you can have, and there's nothing they're incompatible with. Thief costs 2. There's no limit. They're incompatible with knights. I would imagine that in this fiction, thieves would be quite happy to adventure with knights, but because knights won't adventure with them, then it still says they're incompatible. And then we have a wizard, and the wizard costs 15. So obviously in this setting, wizards are meant to be sort of more powerful than the normal adventurer you would run into, quite significantly more so than thieves. They cost 15, and there's a maximum of 1 per party. Perhaps that's rarity. Perhaps it is the nature of wizards that they all hate each other and they're all scheming against each other, and so they won't have anything to do with each other. That's often the case in fiction, that wizards are so solitary. Sometimes you have wizards' guilds and stuff, but in other fiction, wizards are sort of notoriously solitary, and are always building towers and kind of trying to keep secrets from each other and so on. And so if I, let's say I choose a thief, well, we now find that I have 23 points to spend. And although that's enough to afford a knight, because they're incompatible with thieves, the knight is now greyed out. They're not an option anymore. Which of course meant for this version, I had to make black and white versions of all of these pictures. I had to have grayscale versions of all of these pictures. And so I can add a wizard. A wizard costs quite a lot, so that gives me 8 points. And so if I get rid of the thief, now I can have a knight, and just those two take all my points. So because I have no points, I can't get anything. I might decide, oh geez, I don't know if I want only 2 members of the party, so maybe I'll get rid of a knight and add a couple of barbarians, say, or a barbarian and a couple of thieves, something like that. And so I have 1 point left, but that's not enough to get anything. So I can press continue, and perhaps that 1 point that I have left over, perhaps that would give me slightly more money to buy equipment or something like that if this were a full game. So that's what it looks like. Let's have a look at the code. Now, because I have gone through the original version, and this is mostly the same as the original version, just a couple of additions, I'm only going to talk about the bits that are different. So I'll be skipping quite a lot. So this page where you add people to your party, that's entirely the same, so I'm not going to deal with that at all. There's the differences are in initialize. There's quite a lot of extra variables. There's this new page where we create the hover text, and then there's a few differences on the choose page. So let's go through those, starting with initialize, because that's where the program starts. Let's zoom in a bit. So I'll go through all of the variables. We have $A, which is an array, and each slot in this array is a slot in the party. And if it is 0, there's no one in that slot, and if it's a number, then that refers to a particular class. Then we have B, which is the number of members of a given class currently in the party. We need to keep track of that because there are maximums for some of them, and because some classes are incompatible with some other classes. We have the number of classes, we have the current number of party members, we have this new array, which is I, and it is incompatible pairs of classes. And there's only one, that if I wanted to add more, I'd just go set I2 equals, and then add another array, and then I might add 2 and 4, and that would mean that class 2 and class 4 are incompatible with each other. As it is, the only incompatibility is 1 and 3, which is knights and thieves. We have HT, which is the hover text for each class. We have $L, which is the limits for each class, but 0 means unlimited. It doesn't mean a limit of 0, because of course if there was a limit of 0 you couldn't have them at all, and there wouldn't be much point having a class that you can't have. So I suppose you could start it that you can't have it, and then you can unlock it later in the game or something. But anyway, 0 in this case means unlimited rather than a limit of 0. So we can see there's a limit of 2 for class 1, which is the knights, and a limit of 1 for class 4, which is the wizards. We have P is the maximum number of party members. N is the name of each class. R is a variable that it's an array again, and it is set up each time you load the choose screen. Most of the action takes place on the choose screen, and before it loads anything or displays any pictures, it goes through each class and says, is there any reason why the player can't have a member of this class at the moment? And if so, it sets the relevant slot of R to 0, and otherwise it's 1, meaning yes, you can have them. T is the number of points you've got to spend at the start, and V is the cost of the different classes. And then, as usual, I've got Z, Y, X, W as temporary variables. Normally V would be in there as well, but I decided to use V for the cost of the classes, probably V for value. And then we have 2 for loops, FOR loops. This one goes from 1 to P, so from 1 to the maximum number of party members, and it sets all of the slots in the A array to 0. And this one goes from 1 to C, so the number of classes, and it sets all of the slots in the B array to 0. So B is the number of members of each class that are in the party, so obviously that's going to be 0 at the start because it's an empty party. And then we go to this new page, which is create hover text, because the hover text is more complicated, and it would be sort of a waste of time to have it recreate the hover text each time it loaded choose. So let's go to have a look at the hover text. We have a for loop, which goes from 1 to C. Well, that makes sense because we're trying to create the hover text for each class. And $HT is the hover text array. So we set $HT square bracket $Z n square bracket equals NZ, which is the name of the class, plus quote and hash 13. And hash 13 means a line break in this context. In this context, there's a slightly different way of indicating line breaks. We normally do them like that, less than, BR, greater than. but when we're displaying hover text, it has to be and/13. It's just slightly different systems. Twine doesn't have its own system for hover text. It's just using HTML, and so the conventions are slightly different. So and/13. So we have the name of the class, a line break, cost, the relevant slot in V, whatever the cost is, then another line break. Then we have a look at $LZ, which is the limits of how many you can have in the party. If it's equal to 0, then we add to the hover text the phrase no limit. Otherwise, we add to the hover text capital MAX space, and then the limit per party, so max 2 per party or max 1 per party or whatever it may be. And we do that for every class. Then we have to do the messages about incompatibility. So we have another for loop that goes from 1 to I.length minus 1. I've spoken about this before, but I'll talk about it again. When I is an array, I.length is to do with how many, or the highest slot that has been given a value. In this case, the highest slot is 1 because it's not much of an array. It only has one example to demonstrate it. But so it looks at this. It says, what is the highest slot that has been given a value? Well, the highest slot that's been given a value, and in fact the only one that's been given a value, is slot 1. And so it says, this must have a length of 2 because it assumes that you start from 0, as things in computing often do. They start from 0. But I don't start from 0. I find that confusing, and I generally start from 1, or counterintuitive if not confusing. And so we want to go we want to start at 1 and we go up to I.length minus 1. And I.length is 2, so of course 2 minus 1 is 1. So it's going to go from 1 to 1. Or if there were 2 slots filled in, it would go from 1 to 2, or 1 to 3, or 1 to 4, whatever the number of slots. So basically it's saying go up to the highest slot of I, and for each of those slots, we're going to set these 2 temporary variables because it was easier to do that than to write out $I, $Z, $1 and $I, $Z, $2 each time, or at least it's a bit easier to follow, I think. So we look at the 2 numbers. In this case, it'll be 1 and 3. And then we set HTY. We add to that a line break, and it says incompatible with, and then the name of class X. And then we do the opposite to the other slot. HTX equals HTX plus a line break incompatible with the name of class Y. So that's how the knight has incompatible with thief in its hover text, and that's how the thief has incompatible with knight in its hover text. So once we've set up the hover text, we go to choose, where, as I say, most of the action takes place. Most of the player's going to spend most of their time loading the choose screen in this part of the game, if it was a part of the game. So we are going to, the game asks itself, is there any class that the player can add? And at the moment, we'll set it to 0 by default, but then if we find a class that the player can add, we'll set it to 1. And the only reason we do that is for the message that we're going to print here. If Z is equal to 1, we're going to print the message, click on a small picture to add a member to your party. And of course, if all of the classes are not addable at this time, well, that message would be wrong. So we don't want to display that message unless there is at least one picture that you can click on. So then we have a for loop that goes, we have a for loop going from 1 to $C, i.e. to the number of classes, and that goes all the way down to here. And what this for loop is going to do is we're going to fill in the values of R, remembering that R is the array that is set to 1 or 0 for each class, and it's whether that particular class is pickable at this time. And if we find one that is pickable at this time, we're going to set Z to 1 for that message. So let's look at what this does. We set it to 1. So we set it to 1, and then we're going to go through and look for reasons to set it to 0. First of all, if H is equal to P, which means if the current number of characters that we've chosen for the party is equal to the maximum number of characters. In other words, if the roster is full, well, if the roster is full, of course, we can't pick any class. So if that's the case, we set RY to 0. Otherwise, if the class is too expensive, if $T, the number of points you have left, is less than the relevant slot in $V square bracket, $Y end square bracket, then the class is too expensive. And so we set RY to 0. Otherwise, what if the class has a limit and we've reached that limit? Well, we say if $L, $Y is greater than 0, because if $L, Y is equal to 0, then that indicates that there is no limit. So if $L, Y is over 0 and $B, Y, the array that covers the number of members of each class in the party at a given time, if that is equal to its limit, well, then we set RY to 0 again. Otherwise, it looks like it's fine, but we have one more thing to test. And we test that with another for loop. So what we're doing here is we're going through I, and we're seeing whether we can find a class which is incompatible with the class that we're looking at, and that class has at least one member in the party. So we go from 1 to C, and we say, is B X over 0? In other words, is there at least one member of class X in the party already? If there isn't, well, there's no point talking about incompatibility because there's none in the party, so that incompatibility is not going to come up. So I say, yeah, well, all right, there is a member of this particular class, class X, in the party. Well, then let's go between 1 and $i.length minus 1. In other words, let's go through all of the slots of the I array that have filled in. And this is a slightly complicated looking piece of code, but it is a lot less complicated if you realize that the first bit and the second bit are basically the same. And I'll demonstrate that by putting them sort of under each other. You can see that they're basically the same, except that the numbers are in the different order. So if $I, $W1 is equal to Y, and $I, $W2 is equal to X, or the other way around. So if $I, W2 is equal to Y, and $I, W1 is equal to X. So we're looking for, what that means in sort of English, is we're looking for a pair in the I array. Remember that the I array consists of, the I array consists of, each slot of it is itself an array, so it's a two-dimensional array, and each of those secondary arrays has a pair of numbers indicating two classes which are incompatible. So if in I, sorry, get back to where we were. If we can find in I a pair where one of the pair is Y, that is, one of the pair is the class that we're looking at, and the other is this class which is present, then we set RY to 0. Because if we can do that, that means that there is an incompatible class that has at least one member currently in the party. Well, that means we can't add any members of this other class. And having done all that, all those checks, then we say, all right, at the end of all that, is ry equal to 1 still? Have we not found any reason to eliminate this particular class from being compatible at the moment, from being choosable at the moment? If so, set z equals 1, because then we can give that message, click on a small picture to add a member of your party. So now we're going to display all of the small pictures, and the only, the first big difference, it'll say you have T points to spend. We're going to go through every class, and we're going to start by setting y to this text, and it'll be, and I'll type out what it would be. It'll be, we're doing this thing where we, which I often do, which is you have a temporary variable and it becomes a very long string, and at the end you print it. And the reason I do that is because if you sort of, instead, you could just say, well, why set y to that? Why not just say print all this stuff? And the answer is, if you print stuff and you have code that's if and then and stuff, sometimes it doesn't quite join up the text properly. Sometimes this div might not match up with, the logic of the program might not see that this div is matched up with this div, and it might either generate an error, or sometimes it prints things as text that are meant to be code. So we do it by creating a big long string and then printing it all in one hit, and then the program doesn't have any problems understanding, all the commands. So it's going to create something like this: div title equals, that slash quote just means put in a quote. It means here's a quote, but that quote isn't indicating the end of the string of text. It's a character that I want you to put in the string. So div title equals quote, then we add ht z, so that'll be something like thief and /13 cost 2 and /13 no limit. All of these and /13s will be displayed as blind breaks. Incompatible with night. Right? That I can't spell. Incompatible with night. And then we add another. We've got another one of those slash quotes, so that would be like that. R/S, and then it might be, well, in the case of the thief, it'll be S3. Because S3 is just the name of the picture that I've saved. S3 is the small picture of class 3. S3G is the small picture of the class 3 grayed out. So we'll end up with something like this: div title equals, and then quite a long bit of text. And when you have div title equals and then stuff in quotes, all the stuff in quotes becomes the hover text. So that's just setting up the hover text. And then we have this beginning of an img command. Then we say if rz equals 1, we're going to add this. And if rz does not equal 1, in which case it will equal 0, we'll add that. Well, this one's simpler, so I'll do this one first. We add g.png. So and then we down here we add /div and print everything we've made. So if the class isn't choosable, we get something reasonably simple. We get div title equals and then all the hover text. We get this image command which just says go to the art folder, look for s3g.png and print it. And if the class is choosable, we get something that's quite a bit more complicated. It might look like this. So we have y equals y plus dot png, n square bracket add, and then we have z to 3. Now z is just going to be the class, excuse me, that's just carried over to the add page. and this is what Y and Z mean. Y is the slot where we will put a character of class Z. Y is always starting at 0, and then it goes through and looks for an empty slot. But the thing that carries over is Z. It's saying, okay, add a character of class 3 to the party. But we won't go through this because I did go through it in the original video. But all you need to know is that Z is the number of the class that we're telling it to add. Okay, so let's scroll down to here. Okay, so Z to 3, $Y to 0. Well, Y is always going to be 0 because that's just the slot number. $T to $T minus VZ, which is the cost of the class. So all of these, everything that's in here is things to change, variables to change if the player clicks on this picture. So the first part of the image command is what picture, and in this, what we're doing here, it won't be G, it'll just be s3.png. The second part is where do we go if the person clicks on the picture, and we go to add. And the third part is what variables do we change before we go to add, which is optional. You don't have to. You can just have a link without it changing any variables. But in this case, we are going to change variables. So set Z to 3, which means tell it to add a member of class 3. Set Y to 0, which means it's just to do with which slot it's going to put in. Set T to T minus VZ. In other words, take the cost of the class away from the current points that the player has. And $B3++, which means add 1 to the relevant slot of the B array, because the B array is keeping track of how many members of each class are in the party. And of course, if we add 1, well, that means there's 1 more member. And then we just have n square bracket to make it a proper command. So we have square bracket img square bracket the address n square bracket, okay, we're making it a link, and it's a link to the page that's within the square brackets, in this case add n square bracket, here's all the variables that we need to change if the player chooses to click on that particular picture. So if the player chooses to add a thief, well, we need to take the cost of a thief away from their points, and we need to note that we have 1 more thief than we had before. And that's really the only difference in adding things is that we need to. The only real difference in adding things is that we need to take those points away and add to the B array. And now I'm just going to scroll down. This is a different table. This is a table where we have the current party, and if you click on a picture, that's that's removing the member. Now the only difference here is that we've got all these variable changes at the end. So again, I'll just type out what it would print, an example of what it would print, to make it a bit easier to see. So we have square bracket img square bracket art/c and then a number. Let's say we're getting rid of a thief. .png. So c3.png is just the big version of the thief picture. It's the one that appears in the second row, the row that's the actual party. So we have 3 versions of each class picture. We have S3, S3G. S3 is the small picture, S3G is the small grey picture, and then C3 is the big picture that appears in the second row. Then we have that it's a link to choose, which means it's going to go back to this page. But before it goes back to this page, it's going to make some variable changes. First of all, A4, for example, if we're clicking on the 4th slot of the party array here, A4 will be set to 0. In other words, this slot is now empty, whereas previously it had a thief. $H minus, well, that just means there's 1 less member in the party. Whereas up here, no, we don't have $H++ here. We have $H++ in this on this page. We could have done it. We could have done it there for symmetry, but anyway, either way, yeah. So with the image, the first part of the image is the location and name. The second bit here is where it's a link to. The third bit is what variables we're changing. Well, we're changing A, let's say 4 to 0 if we're looking at slot 4. H minus minus. $T to $T plus the value of the class, because of course if we eliminate a member from the party, well, we should get the cost of that type of player, that type of character, sorry. If we, shouldn't say if we eliminate a player from the party. If we eliminate a character from the party, we should get the cost of them back. So $T becomes $T plus the relevant value, which is $V, $A, $Z. $A, $Z is what character is in slot, the relevant slot number Z. And so we look at that, and it will say 3, and then we look at, okay, we'll look at $V3. What's the cost of a member of class 3? And $B, $AZ, minus minus. There's now one less thief in the party, or one less whatever we've done. And then we just close that off with n square brackets. And that will print the big picture. So those are the differences. The only difference with the previous version is that now is basically these two, as well as setting the slot to 0 and lowering the number of characters in the party. We also need to give the cost of that character back to the player, and we need to reduce the relevant slot in the B array because there's one less member of that class in the party. And that allows us to have a slightly more complicated system of picking classes, where we can have points and limits on particular classes and incompatibilities of particular classes. So I hope that was useful or interesting to at least some of you, and I hope you will tune in next time.